Hello everyone and welcome to Handmade Hero, the show where we code a complete game live on stream. We are at an exciting what can I say, right? It's bristling with excitement. We're at a bristling point in the code where we finally get to dive into our debug data that we've spent a bunch of time figuring out how to collect reasonably well. And yesterday we added just a little bit of interface code to our debug overlay to allow us to kind of hover over things and get some info on that. So today we're going to get to play around a bit and do some fun things, I think. What I'd like to do is I'd like to make it so that we can kind of interact with that debug data, do something kind of fancy where we can, like drill down into it and like look at individual sections of it more, that sort of thing. So I don't know exactly what we're going to do there. I don't have a concrete plan, not really in terms of what we're going to do in the code, but more so I don't necessarily know the best way to visualize some of this stuff. So that's a little bit of a thing that's up in the air. But we will start playing around with it and see what shakes out. Basically, our goal is just to make something that'll be kind of easy for us to use and allow us to do something, to quickly kind of inspect our data. So I'd like to kind of jump right into that. It's day 189 here, which means that if you pre-order the game on handmadehero.org and you would like to follow along with the coding that I'm doing, what you want to do is take day 188 source code, unpack that into a directory, and then you will be at the same place that I am today. And so if you are interested in following along, that is the thing to do. All right, here we go. Let's get started here. Where we left off, if you recall, is we had sort of the ability to now like pause the game. Well, we don't really pause the game, like the game still runs, but we pause the debug processing, right? So as the game is running, as we're coming along, we can at any time pause, and then we have this sort of information over here, and we can go through and look at what it is. So if we wanted to know what that was, we can see that that's like something called do tiled render work, which of course we know is in our renderer. We know how many cycles it took, that sort of thing, right? And furthermore, we can kind of see, just by looking at this now, what takes most of the time. You can see that game update is this giant thing here, right? So we kind of have a good idea of what's going on. Like here's frame rate weight, here's frame display, here's our debug collation, right? So we can kind of see like pretty quickly, right, what's going on, and it's kind of nice, right? It's pretty handy. However, handy as it may be, what the problem that we have is we have a lot of more debug events. We're only displaying the top level ones here. We don't have a way of like getting in there and finding out like, all right, I see that game update is taking this big chunk of time. I would like to now expand that and say what's actually in there, like what's actually underneath that taking its time, So that's what I'd like to do. And I was thinking, these frame rate bars, maybe they'd be better off going horizontal. And the reason I was thinking that is because, if they were horizontal, we could probably put the name of the thing inside there potentially even, or there's stuff that we could probably do that would make it a lot easier for us to use. And so what I'd like to do is just kind of start working with that. Like I said, get this into some state where we could kind of inspect it, maybe put it here so we can kind of interact with it that way. I don't know. But that's what I'm going to start playing with. So again, we have most of the stuff we need. We just have to now do some work to kind of pull it together and make it into something that's kind of usable, right? So I'm going to start to try a few things in that area and see what we can do. So here we go into handmadedebug.cpp. So if I wanted to do something like that where I was going to turn it sideways, if I wanted to turn it sideways, that's actually not too difficult to do, right? Because this is the only code that really has anything to do with the chart, right? This is the thing that draws it. So all I really have to do to turn it on its side is change sort of the way that I'm interpreting these variables. Instead of saying that I've got the chart height and width and they mean a certain thing, I can just sort of rotate it on its side. So if I want to, I can say, all right, the chart width is going to be instead the chart height, and that's going to be like how many we have vertically, and the chart width is going to be the thing that's fixed. It's going to be a certain amount, however much that is. And since it's going to be running from left to right, we can also make it a little bit bigger. We could make it 1,000 could be the entire width of the chart, so that things can be a little bit bigger. So that's also kind of cool. And then for our lanes, right, we're going to have lane heights, not lane widths. So that's good too. Same thing with bars. We got bar heights. That's going to be the lane width, the lane height, right, times the lane count. And I'm going to make those lanes, I'd like to make those a little bit bigger. So I'm going to make them 20 pixels high. I don't know if we've got enough room for that. We'll see. I hope we do, but I don't actually know if we do. And so the spacing there, again, bar height, the spacing on it's going to be, whatever the bar height is, plus some little spacing so we can leave some space between the bars, right? Okay, so there's our kind of chart height. That's the total height of the chart. There's our chart left is still going to be the same, right? Our chart min y. Now we don't really have a min y so much. We kind of have like a starting point, and we're going to go down the screen on that. So we're just going to call this chart top for now. And I think that is what that would be, right? Starting at the very top of the screen and going down for now, right? And we'll sort of think about maybe doing some fancier stuff as we pull up. But right now, we just want to kind of get it, drawing reasonably. So the scale is again going to be the same sort of stuff, but now we're gonna be scaling based on the width. So that's really all we need to do there. So as we come through here now, we just have to kind of rework the way that we're making these rectangles. That's really the only thing that we're going to have to do. And so now what we have is we've got these guys, the sense of these guys is kind of going to be a little bit reversed, right? Instead, we've got the stack X is going to start with the chart left, right? And the stack Y is going to start with the chart top. And then it's going to go down based on how many bars we have, right? So we'll kind of come down, 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 So then we've got our regions here. We're going to make our, same stuff as we were doing before. We've got our colors. And then the min and the max Y are actually now going to be min and max X, right? So we're going to start at that stack X that's kind of advancing forwards. We're going to add the scale just like we were doing before and get a min and max X. And then we've got to sort of put those in here. So now what we have to do is say, all right, we've got a this min X and a this max X. We know those, but now we have to sort of do the equivalent that we were doing before for the min and max Ys, right? So the min and max Ys are going to be a little bit different. We have the stack Y that we're starting with, but the max is actually, since it's coming from the top down, and again, Y gets decreases as it goes down the screen, that stack Y is going to actually be the maximum value, right? That's the actual maximum value. It's up at the top. And the minimum value is actually going to be taking that top value and subtracting away how big a lane height actually is, right? So that's how that's going to work there, right? And so this is actually the value that we would be using, and to place the actual lane. And then for the one that's lower down, right? The one that's lower down is actually going to just be the lane height plus 1, right? Okay. So once we get that rectangle, we can push it on there. There's not a lot more that we would have to do. That's pretty much it. But now we have to make sure that we actually advance our stack properly. In fact, where is that code? I guess we don't have to do that anymore because I guess now that I think about it, that stuff's all handled in the collation code. So we don't even have to worry about stacking things on top of each other. We're kind of just done at that point. That's really all there is to it. So yeah, that's kind of nice. And there we go. So never mind. I guess that's pretty much it. And so then what we would need to do here is this guy where we kind of mark off the territory. That's going to be an up-down kind of a line. I'm going to turn that off for a minute because I think we should probably think about what we actually want to do there. Think about that a little bit harder for drawing in like marker lines so we can tell how fast it's going. So I'm just going to see if we got our chart turned around reasonably here. So there we go. Okay, so it looks like we're almost there, but it looks like I messed up a little bit on the. You can see like these guys are really thin for they're getting wider. So it looks like I didn't quite do the widths. I'm sorry, the chart heights properly. So let's make sure we've got that set up properly. So we've got oh yeah, right. That's just a stupid mistake. I incremented the wrong value. I wanted to go to the next lane index. I didn't want to change the lane height. So yeah. Okay. So now we've got a more sane looking thing. This is roughly what I was expecting to see, right? So that's all good. And now we've kind of got a thing that we could work with a little bit more. It is still a little too long, but then again, like I was saying, that's just because our frame rate is really bad at the moment, right? If we were to actually do this at a reasonable frame rate, which we could do pretty easily, we could probably do it just by having this be optimized for starters, then I think it would fit on the screen relatively well, right? Or maybe not. I take it back. So, you know, the other thing that's kind of interesting is I don't know why our frame rate wait is so crazy. You know, why the frame rate wait is taking such a huge amount of time. It's kind of interesting, right? Because it doesn't really make any sense. And if we look at that code, you know, do we have a bug in there? That may just because that's our code that's doing the sleeping. I'm not entirely sure, but we could see here. So here's our code for frame rate wait, right? You can see that really all it does is it just, you know, tries to figure out how long. We do say that it's probably buggy, so that's fair, being fair to us. But let's take a look. So what happens here is we have a work counter. We see what time the work counter's at. We see how long it's been since the last time we marked the counter. And that's the last thing we do, right? So that's how long it's been since the last one of those. We then say that we would like that, I guess, to be, seconds left, we would like that to be however many seconds we expect there to be per frame. So if it's less than that, right, then we kind of need to, then we need to do the sleeping. So, you know, now that we're doing a bunch of stuff kind of after that, that does create a bit of a problem. Like what we really probably want to do there is we want to just see, we want to see how much time has elapsed since the last time we displayed this stuff. You know what I mean? So because really that's what we're trying to trigger the time to. And if too much time has elapsed since the last time we actually displayed something, we would want, you know, we would want to not wait at all. We'd want to just keep going. At least that's, you know, my understanding of, that's what I feel like should happen, right? And so then as we go here, we do like some spin lock stuff to try and get us right up to the time. And that's really about it. Nothing too weird going on. So yeah, I mean, again, it's kind of a problem. One of the downsides of programming on Windows is there's no hard real-time stuff happening there. So it's pretty hard for us to actually say, hey, operating system, you can give some time to somebody else, but you need to come back to us in time for thing X, whatever thing X is, right? So yeah, it's one of the reasons why you tend to try to use VBlank when you're presenting through something that actually has VBlank support, because it's more reliable than trying to do this. So yeah, so this is a little janky. So, you know, one thing we could do for now is just turn it off, right? We could just say, you know, this guy goes away, and we don't try to give anything back to the OS, right? But that also means that our I don't know what happened there. I don't know what, we're gonna have to look at why our region counts sometimes overflow. It probably has something to do with our threading stuff, right? But so let's take a look at this. So now we have our frame display and we have our debug collation, but we don't have any more of the frame weight in there, and so that's a good thing, right? Debug collation is still quite a bit of our time. In fact, it's taking up a tremendous amount of time, right? You can see all that extra time in there being taken up by the debug collation. So yeah, but at least now we don't have that particular thing in there, so we don't have to worry about it kind of ruining our lives, right? So that's good. All right, so, you know, definitely better, right? Definitely better, but still not perfect. So let's go ahead and take a look to, I mean, the other thing I guess we could do today, if we wanted to start doing, if we wanted to end out the week and start next week focusing on the UI stuff rather than doing some UI now, the other thing I could do is try to start keeping frames incrementally so that we can cut down on that debug collation time. That's another thing that we could do. I don't know what the right solution is there. But yeah, getting rid of the frame rate seems like a pretty important thing to do because obviously this code is just causing a little bit too much of a pain. You kind of want to be able to sleep to give some time back to the OS, but in this case I'm not really sure how useful that would necessarily be how reliable we could actually get that to be. So we may want to just wait until we have actual vblank support there to actually do it. So to do Casey, leave this off until we have actual vblank support, question mark, or something like that. Okay, so moving back here. So what I would like to do, and again, you know, like I was saying, if we take a look at what's happening now, you can sort of envision how yeah, we should probably take care of that as well. In fact, that hits enough. I think I'm just going to make that decision. Since it's the end of the week, we get this problem a bunch, and we have the speed problem as well, right? Where we have this problem where debug collation is just taking a ton of time. So I feel like we should just go ahead and try to kill two birds with one stone and say, let's go ahead and try to make debug collation be incremental, right? Instead of debug collation being this thing that, you know, that we have to have all these like constants for and just nasty stuff like that. So if we wanted to do something like that, right, here's the way that I would suggest we do it. We have debug frames, and what I'm going to do is I'm just going to have a debug frame thing where we just do like, I don't know, well, you know what, we can still actually probably do debug frames in just an array. And we could just say, all right, we're going to keep some number of prior debug frames. I don't know how many of those we should actually keep, but we will, you know, we'll keep however many, I guess, however many the data supports or something. And then what we can do is we can have our collation be more of a permanent thing that runs forwards, right? So the way we would do that is we would say something like, these guys are not removed like every frame. Like this stuff doesn't redo every frame. Instead, what it does is it restarts itself every time we ask it to, right? Because right now what's happening is we have a memory arena and we start collating things, and then every frame we restart and start collating again. But what we could do instead is just say, oh, keep collating, and then the only time we're going to actually restart is when we actually decide that it's time, you know what I mean, for a restart, right? So let's do the simplest possible version of that first, and then we'll try a slightly more advanced version of that, right? So here we go. What I want to do, let's see if this works, is assuming that we are not paused, what we're going to do is we're going to allow the collator to run forwards, and we're not going to do this begin temporary memory thing, right? So instead, we'll let begin temporary memory happen here, and then what we will do is we will only restart. We'll call collate debug records, like so. We will only restart when we actually run out of frame storage, right? Does that make sense? So this is going to be something, and in fact, I guess we can test it like this as well. We could do it in 2 steps. Here we go with internal void restart collation, like so. And the way that would work is we would say this thing here, yeah, this thing here can happen whenever we want. So we'll go ahead and do that, debug state, and we just call restart collation with debug state. Excuse me. So yeah, assuming that we don't, you know, want to do anything else, we just restart, and this is the same way that we were doing it before. Oh, and I guess I have to still have this defined until we finish that part off, right? So pound define max regions per frame. I don't know how many, but there's a bunch. So there we go, right? And that's just working the same way as before. And we still have a ton of debug collation time on the wall there, on the wall clock, as you saw. So now the question is, what if we just, you know, kind of did it in sweeps? So now we just let debug, you know, we look at collate debug records. And if we take a look at this, you know, collate debug records kind of does this sort of initialization thing, right? What if I move that out In fact, we could even imagine moving this out and still running it this way. So inside restart collation, we actually do that. So the whole thing gets done, right, like at that restart point, right? Again, should just work, and it does, so that's all good. So now inside collate debug records, when this thing's going through, what we can do is we can sort of move through those event array indexes. We can just remember the last one we processed and start there. So instead of starting at the invalid array index +1, we can just start at the last array index that we used. Does that make sense? So when we do a restart, when we do restart collation, we do something like debug state, event or collation array index, something like that. We can just say, oh, okay, there's the invalid event array. When we do the restart, we remember which one that is, and we start at the one immediately after that. And then in here, instead of passing that in, we just always start from whatever the collation array index is. And in fact, we could even do this as a while loop. We could just say, well, actually, you know what? I guess it's literally this now, which I realize is not particularly exciting. But then the event array index is now actually debug state collation array index. So we're just gonna kind of move that guy through, right? Like so. And he is now a stored value. You know what I mean? And we could just avoid doing that for the rest of this by just sort of grabbing it out as well. Right? Something like this. Okay. So we've got collation array index now, but we need to store that up here. So that would be something like, U32 collation array index. There we go. Invalid event array index is an undeclared. Oh, right. Still have to pass it in. I take it back. So then in restart collation, we have to pass the invalid one. And the invalid one, of course, is this one. OK. So there we go. So now, as we do this, well, assuming that we can get past that sort of annoying roadblock here, which we're sort of working towards removing permanently. So now when I do this, everything is still working the same way, but now we're using a permanent variable for the collation. So now what we should be able to do is actually just do this incrementally. So we only actually process one the new information every time. We just process. We don't restart every time. We just keep going incrementally through, so we don't have to reprocess all the debug events. We only process the ones that came in since the last time we were called. And then in terms of restarting the collation, what we will do is we'll only restart the collation when we hit an actual limit of the frames that we can store. So, whatever that frame count is, whatever our max frame count is, so in here, right, when we did our frames, you can see that we only have room for max debug event array count times 4. That's how many we've got. What we can do is as the frame count gets up, when it goes, I'll just for now say it'll be this or something like that, just for sake of argument. I'll do, if the frame count has gotten up above that, frame max, what was it? Debug event array count, there we go. If the frame count gets up above that, then we'll restart. Again, just for now. So debug state frame count, if it's greater or equal to the max debug event array count, then we restart. So let's see what that does, besides just instantly crashing. Oh, and we'll probably have to store a current frame as well, if that makes sense. So yes, obviously one thing that's probably the thing that we would need to do is actually call this once, right? That's pretty obvious because we have to start somewhere. But then we would restart every time here. But yeah, good point. Current frame there is going to have to be tracked as well, because that's actually a global variable outside that loop, so it's got to persist, right? So current frame goes away, and it comes into here, right? So this is like, collation frame. And so when we do that restart, debug state collation frame, we set that to null. And again, all I'm doing here is I'm making this loop be something that runs incrementally instead of just, one time through the loop. So now we just replace everywhere that was using current frame. We use debug state collation frame. That's it. Oops. Current frame, debug state collation frame. And that should be it. And so now we'll see, I don't know how this will end up working. It looks pretty good so far. Let's go ahead and break out here. Okay. So unfortunately now, it still looks like there's a fair bit of time being spent there. I'm not actually sure why. I feel like that should have dramatically decreased the amount of time involved. And to be fair, it did decrease the time, just not as dramatically as I would have expected, right? The time appears to have gone down, but it did not go down to the extent that I would have expected. So I'm a little confused about why that would be. Let's figure that out right now. Okay. What actually has to happen in here? Collate debug records. We don't do anything else, right? Yeah, we don't do anything else. So collating the debug records is the only thing that we're talking about there, right? That's the only thing that's actually time spent, as far as we know anyway. So if I go up to collate debug records, I take a look through here, we're going to come in, we've got a particular invalid array index. What we know is that as we go, we start on whatever that index is, whatever the last one was that we were using, and then we go till we hit the invalid one. And that should, I feel like that should have worked. And we should only process like one of these, right? We then go through all of the events, which is what we would expect to do, and that's all totally fine. Nothing particularly weird there, right? I also think we don't need, this code is never going to get used anymore. It's old code, let's get rid of it. Let me go ahead and move this up as well. Yeah. So I'm not really sure. You know what though? I do think I know what this is. We need to be able to store more frames, otherwise we're always going to be at that max debug event count, right? So as we run through, if we don't check for that or something high as our reset condition, the sort of fake, faux reset condition I set up temporarily here, if we don't check for that, then we actually would restart every time because there's always going to be that many frames in the buffer. So that was kind of dumb, to be fair. Let's see how this does. If this does any better. No. Yeah, a little bit better. Still not as better enough as I would have hoped. But you can actually see now the bars don't even extend to the end. So it still takes a lot of time to do that operation, it would look like, right? For a lot of these guys. And so, I don't know, it seems like a little unrealistic, but maybe there's just that much data, and maybe the stuff that we're doing is, maybe the way that I'm doing it is janky enough that it takes that much time. I don't know. It warrants a little bit further, a little more attention, I would say, because it feels like there shouldn't probably be that much stuff necessary. It doesn't seem like it should be quite so time intensive. I'll double check and just see what happens if we compile the collation code with optimizations on, just so I can get a feel for where it's at there, but we'll see. All right, so with optimizations on, it's not so bad. It looks like when we actually, so you get obviously spikes in terms of how long it takes to collate when we hit things like the ground chunk filling. And that makes sense because those things really pound onto the renderer and stuff, and I think and other things that we have instrumented. So that's not surprising, but yeah. So at least if we go optimized, we can actually sort of have these guys running and the collation running totally in line with everything else, and it's not a problem at all, apparently. So that's pretty good too, right? Yeah. Now I'm not sure why right-clicking turned off everything. So if the debug state is not paused, what is the problem? Why when I right-click and we go to be paused, why is it erasing all of my data? You know? That's a little strange. I'm a little uncomfortable with that. That should not be happening. And so I feel like I messed up one other thing there, right? Because I don't know if you guys saw that. We're going through here, I right-clicked, and now we're gone. I right-click again, and we're back. And I don't know, right? I don't know why that would be happening. So that's off-putting. It leaves a bad taste in one's mouth. And so I feel like we should try to figure out why that is. So that's just, all that is setting paused, right? I mean, all that happens when you right-click is you set to paused. And so the only thing that pause does is actually call these guys. So it means that collate debug records would not be getting called, but I don't see why collate debug records getting called would have anything to do with it. Like, it doesn't seem like that would really cause all that much of a problem. So I'm gonna have to, I think, step in there. Also, the other thing I do is that some kind of weird bug we have that only happens in optimized mode? I assume not, but since we were in debug mode, I'll go ahead and just double check, since I don't know. Okay, good. It happens in debug mode. That's always nice. You never want to have a bug that only happens in optimized mode, because then it's a lot harder to inspect the code. But, you know, sometimes you get unlucky. So when we do hit that right mouse button, I'm going to go ahead and see what happens here, why we end up in a circumstance like we did. So I'm going to set the breakpoint. I'm going to set the breakpoint right at when I hit that right mouse button. You know what I mean? So we can take a look. Let's see, where is that at? Right there, I guess. Okay. So there I hit the right mouse button. We set the state to be not paused anymore. So here we come. We've got the frame count there. We're setting it, so that's all good. And this stuff is just doing its little frame drawing thing. And so I'm going to go ahead and just set a breakpoint for the next time we come in through debug frame end, since I'm assuming that's the place where things would go wrong. Let's take a look at our debug state. So if we take a look at this, okay, paused is set to 0. Oh, is that because we have not grabbed it? Yeah, that's because we have not grabbed the debug state yet. So that's understandable. There we go. It's set to 1. We are set to uninitialized. Okay. I'm very interested to know how that happened. You have to admit that's a little bit odd. And it gets reset every time. I'm going to switch back. Here we go. And what I'm going to do here is I'm going to set a breakpoint now to see, does that happen every time? Oh man, you're kidding me. So this whole time we never actually set initialized equal to true. That's pretty good. I feel like that deserves a little out of shame. It's like we have a thing that says whether we're initialized or not, specifically for this purpose. We never actually check it. That might have something to do with it. Do you think? Shocking. Shocking, I say. Let's try that again. Oh, hey, guess what? It turns out that now we don't take very much time to do the collation either. How surprising. Yeah. So now it makes a lot more sense why we were seeing that. It's because it was redoing the whole thing every time. So now our collation's not too bad, and that's pretty great. And you can see the spike, right, that happens in there occasionally. There it is. You can see the spike. That's when we get that reset event, because like right now we still do a clean reset every so often because we don't have it set up to do like sort of movement in there. So yeah, so that's totally fine. But now we should go ahead and address that as well. However, you know, there's one, I don't know. Yeah, so there's so many things I want to do now, because now that we're starting to get like kind of an interesting little setup here, I'm kind of, I think this is gonna be a lot of fun. But anyway, so I think what I'd probably like to do now is make it so that these frames get stored kind of permanently in a more sort of concise way, something like that. And so that when we do the frame analysis, like they kind of get put out there. And so I think what I'm going to do, though, honestly, because I'm trying to juggle these things in my head, I think I might do the expansion thing here, because we've got 20 minutes, 25 minutes. I might go ahead and do the expansion, because if I do the expansion, then that's going to tell me a little bit more information about what sort of stuff I'm going to have to do in terms of reprocessing things. And so I'd like to kind of see, I want to see that in action first before I go any further, I think. So I'm going to go ahead and try adding the ability to like expand stuff out here. And I'm not sure exactly how to do that yet. I'm not sure exactly how to visualize that, is I guess what I'm saying. I guess we just like blow out that bar to be that size or something. I don't know. Let's figure it out. So, right. At the moment, you can kind of see in here that the way we're doing things is we do this first open block parent equals 0 thing. So what that does is it says we're just throwing away any timing blocks that happen underneath some other timing block. So the top level timing blocks show up, but the timing blocks below it don't. So all I would have to do to modify this to show me things below a certain timing block, right, is I just need a way of making this detect some other case, like things that are below something besides just 0. You know what I mean? So if you look at our Handmade platform stuff here, our debug record structure definitively identifies a particular place where a particular timing block. So what I could do is, instead of looking at the parent thing here, where I do like first open block parent or whatever, instead of looking at just that parent pointer, which again, if we look at what that is, that parent pointer is actually pointing to one of these things, right? Instead of looking at that, what I could do is look at the debug record to which that thing corresponds and check against that. So for example, in one of these open debug block things, right, I could say this is like the source. And so then when I create one of these open debug blocks, you know, what I could do is when I create one and I write down the stuff, I could just write down its source as well. So now I know for whatever, you know, block that is, I know which source it is in that little list. So then what I can say is I can do something like, you know, make a thing that's like if is direct child of or something, and I can say, you know, is this event that I'm talking about here the thread first open block so the matching block, right? This was this. So it's that original guy, the guy who was open. when we're about to close whichever block that we're looking at, when we're about to close it, what we want to say is that guy's parent this some debug record? Does that parent come from a particular debug record? Right? So we can ask, or we could even say, is from debug record. So we could say matching block parent, whatever that is that from our, scope to record, whatever that is, right? And so what I'll do is I'll say, yeah, you know what? I could even do this slightly differently. I could do record from equals get record from, or just scope to record. Yeah. So that would just say, for this guy, give me the record to which it corresponds. Now, I don't want to access it directly, and the reason for that is because it may be null, right? So I'm just doing a thing here where we say, okay, there's an inline, it returns a debug record, it's called get record from, like so. It takes a debug, open debug block, and all it does is it goes like, okay, the result is what, if there was a block, then it's the block record, otherwise it's 0. So it's just like passes a null through, essentially. Then we can implement the exact same functionality we had before by setting our debug state to just have a permanent record, that's like debug record, scope to record, like that. And then when we initialize things in here, when we do our initialization, we could say stuff like, oh, okay, right, paused equals false, scope to record equals 0, something like that. And off we go from there. And we could also do, didn't we set, where did we set, so I guess we just, because we call restart collation, I guess, that initializes the rest of that stuff. So scope to record is now this thing that we can set permanently. It's set to 0 at the beginning, so this should do exactly the same thing that we were just doing, oops, sorry, source. And so, this is just going to produce the exact same output, so we don't get anything from that. But now what we could do is when we left click on this, we could just say, okay, show us whatever's underneath that, right? Show us show us the things that are underneath that particular block that I just clicked on, And so to do that, all we have to do is say, well, we know what happens. We know we got a was pressed, right? We have that, and we know an is inside rectangle. So all we'd have to do is when we know we're inside the rectangle of a particular region, we could just say like, oh, well, was the left mouse button pressed? If the left mouse button was pressed, then let's set the debug state scope to region, scope to record, to be equal to whatever the record is that we're on. Does that make sense? So here we are in here, and now we can go like right click. And then presumably we can go over this guy and we can like click on him and, well, or totally not do that. And that was a little anticlimactic. I was so ready for that to actually do something, and then it totally didn't do it at all. Whatever. Programming. Like sometimes I just don't even know. All right, so let's go ahead and find out what kind of stupidity is happening there. I'm clicking on this and I'm not getting anything. I should go do the was pressed thing and see what happens. We click. Record is actually something. Scope to record is actually something. So we're actually setting, our UI is working fine, but apparently, right, because that never gets called again, so that's working just right. But apparently this little guy here is not working correctly. So let's take a little gander at what happens there. F5. Oh, duh. We have to, right. Forgot about that. So it was working fine. As it turns out, my bad. It's a little mistake there. I admit that. I apologize. We don't actually recollate anything unless we're running. That's kind of how that was supposed to work, so that's unsurprising. But what that means is that we have to do a collation restart, right? And recollate the records when we actually click something. Because we only kind of inspect that one, we only kind of produce the output for that one area, right? So what we need to do here is we would need to do something like when we have restart collation, and it does that. And then we also have like the collation routine where we do collate debug records, like so. What we would want to do there is we'd want to actually have a way to kind of do that whole step. So we'd want to do something where like restart, so like refresh collation or something, where we can do that, and that would literally just do this thing, the whole bit, right? And so then up at the top here, I don't know, yeah, I guess we'd have to have it somewhere above debug overlay, although I guess I could just leave it down here like this. So internal void, refresh collation, and that just does the restart. Debug state, there we go. And I'll just go ahead and make that be something that we define out here. Okay, so yeah. Now in theory, we can drill down, in theory. Although that does not seem to have been happy about that at all. Oh, right. Yep. I tell you, doing these kind of like little debug things is fraught with peril. It's fraught with peril, I tell you, but it's fine. So obviously we can't refresh the collation in the middle of that because we're in the middle of doing something, so we would have to sort of delay that till the end because we're in the middle of looping over these regions that we're drawing, so we don't want to like invalidate them all in the middle of that. That would be rude, to say the least, very unseemly. So we just do this. Again, pretty easy. New scope to record. There we go. And then at the end here, we do something like this. If, debug scope to record. In fact, we could even do something a little bit more like this. So we could do hot record, like that. So when we come through this beast right here, and we go ahead and take that record information. So out here we do like, debug record, hot record equals 0. Then we could just do something like, when that's pressed, I don't know why that's still here, we'll get rid of that. If the mouse button goes down, then we'll do something like if hot record, then we will take the debug state scope to record. We'll just set that. So we'll say, okay, that's the new scope to record. If there wasn't a hot record, we'll just say, okay, if the debug state scope to record is actually valid, then we'll make whatever it is like go up a block. Well, I guess we would need to know the open block for that though. So we'd need to trace one more thing, right? Which would be the actual, like, we need to know who the caller was. So I guess that's a little premature. So I guess for now I will just clear it, but we should probably think about how we want to handle that eventually. But yeah. So now when we're in there, right, and we can pause. In theory now we can actually look underneath these things and see what's actually going on here, right? There's a render group call, there's the sim region stuff, there's some debug render group things, there's some little guys in there, move entity, begin sim, right? And so I guess what's that tiled render group output, what's under that? Okay, here's some stuff, tiled render work, tiled render work, right? Let's see what's under there. Okay, so we can now drill down pretty good, I guess. Unfortunately, we eventually get to a part where there's too many regions and we can't show them. So that's a bit of an issue. But we're getting there, right? You can sort of see how it's starting to take shape, right? We've got a ways to go. And again, we're not trying to make some kind of professional profiling tool here, but we're getting there. So I don't know, like I want to go in here and see like something's happening, tiled render work. Let's see what's in game update. What's this? Input processing. I don't think there's anything else happening there. Executable refresh. So if I go into game update, what's this? Game update and render, that's unsurprising. Inside game update and render. Okay, so let's see what's in begin sim. So there's begin sim, there's these little tiny pieces of chunks, get world chunk, all these get world chunk calls, right? So yeah, it's starting to be kind of cool. And we can always restart it running and see the actual like, stuff happening in there. And then we can also pop back out if we want to. And so we still have a ways to go before this is actually like anything that's not super terrible at everything. But we're kind of getting there. And you can also see we've got problems in terms of like these things are really slivery, and we'd want to be able to like zoom in there or get some other stuff. And we got a ways to go. We have a ways to go. There's no question about that. But at least we're starting to get there. We're starting to get towards a little bit of a better thing. So yeah, I would say if I want to start something new, yeah, right, yet. So I think what I'll do, because I've got a few minutes left, I think what I'm going to do is I want this debug text line thing to become a more general thing. So what I want to do is I want to do something like internal void text out at or something like that, right? And I'm going to grab this guy, grab him right up. And what I want to do is kind of trim this down to something that doesn't use any globals there, right? Well, not any globals, but it doesn't. Its positioning is said specifically. So you pass into it the string that you want printed, right? So you pass in that, but then you also pass in, like a v2, like a point, like a p. So at x and at y are actual things that kind of get specified here. At x becomes like, p dot x, something like this. And at y equals, p dot y. That sort of thing. And so then this code right here can actually do, we'll actually take out that get line advance for. So that get line advance for goes away. The rest of this stuff basically stays the same, right? And so then this code can just use that code, right? So what it would do is it would do the exact same thing. And then I don't know, these are not particularly expensive things for the most part. So I don't know if I really want to deal with that. But what this would do is it would just call that with add x at y, like so. So this is like a text out at. And it's just, yeah, this should probably be debug text out at. This was like left edge, right? Something like that. Yeah. So now if we take a look at that, it's the same thing, right? But now we can sort of draw text anywhere we want. So instead of this kind of nonsense here where the render group output is kind of annoying and doesn't really look right, you know what I mean? I can maybe fix that to be something a little more usable and say, okay, instead of debug text line, debug text line that's getting called there, what I'll actually do is I'll just call debug text out at, right? Not there. There. Right there. So what I'll do here is say, okay, debug text out at. What I'll do is I'll just use the mouse pointer, the mouse where the mouse is, and I'll print out the text buffer there. And the reason that's a little bit nicer, at least for the moment, right, is because that allows me to actually do something where it kind of hovers with me, right? If that makes sense. Now, we should also probably get rid of that string nonsense. So there's this giant gapping there for no apparent reason. So we should get rid of that as well. And then we also have a sorting problem where, this thing is going to show up behind the bar that it's ostensibly supposed to show up towards. And so the thing that we can do there is we can also just kind of offset it a little bit just for now. There's probably better ways of us doing that. But we can make a little offset now where we do something like, oh, okay, we'll offset it by 10 pixels up or something like that. So now, when we pause, we can just see, exactly what's going on there right next to where we are. So we don't have to look up at the top of the screen. And you can kind of see, like, okay, so we definitely have sorting problems there. So we want to, once we actually sort of upgrade the render to do like a little more sorting stuff, we probably want to have a way of saying, draw that on top, of whatever it is that you're drawing, so you don't get that kind of like hard to see thing. But yeah, so it's getting a little bit better. And that's a pretty easy way for us to be able to inspect what's going on and see pretty quickly. So we can click on game update, say, okay, there's what's happening in game update, there's tiled render group output, there's the nsim, there's the, right? All these little guys in here we don't care about because they don't take any time apparently. Begin sim, etc. Push render element. So yeah, looking pretty good. It's not great yet, but it's getting there, right? 1 hour at a time. Eventually end up with something pretty cool. All right, so let's go to the Q&A. If anyone has any questions about what we're doing here. If anyone has any questions, now would be a good time to ask those questions. Put a Q colon in front of it so I can see it. Let's go. Insofar as, are the events keeping the same colors across frames? The long one looks like it keeps changing. No, the events are not keeping the same colors across frames. I'm not sure how we want to deal with that. The events are actually just purely randomly plucked by order into this color array. What we might want to do is try to make it so that there's a more clear way of drawing what is going where. But I just haven't given it any thought yet. It would be nice to maybe track the colors across frames, and there's actually pretty easy ways to do that. It's just you may have two things that stack up next to each other that get the same color, right? Because we could trivially make it like we know what the debug record is, you know what I mean? So we could do something like, oh yeah, whatever, we use that instead of this. We just do, okay, we've got the record. That's a pointer, right? So we just cast that to a U32. We shift it down by 4, right? And then we mod, or something. Maybe 2, right? What's the record? What is the record? It's called region record. That obviously would always keep the same ones, but we'd have to have a better way of making it so that they were, it picked more distinct ones, or, so these are all do tiled render work, so they are all the same color. But then we have these guys. I guess part of it is I don't know what I don't know the best way to kind of re-randomize that, since they're going to go on even amounts. Like we could multiply by a prime number here or something. And I mean, like this is just pure lunacy at this point. But let's see here. So if we go into game update. There you go, begin sim, render. That's no better. Did I do that right? Yeah. So I don't know. I mean, the other thing we could do is try to actually assign the colors based on the universal index. We know we don't have enough for however many there are, but like, you know, in that debug region thing, where we're actually recording that, let's see, where is that? Debug thread, debug frame region, right? What we could do there is also store like a color index, you know? And I don't know if that's going to be particularly useful or anything like that, but we could, you know, we could even do it relatively for basically for free, right? And so if we wanted to do that, then we just do, okay, whatever the color index is, we look that up, you know, and the color index for the region could just be based on the counter or something. So, you know, inside where we actually record stuff for regions, down in here, we'd do region color index, and we'd use the debug record index, you know, to do that, something like that. And so then they'd be stable across frames, but again, yeah. So we need to draw lines because like these are like back to back, all the same function, but they're different invocations of the function, and that might be nice to see, you know. But yeah, now everything's stable across frames, which is obviously kind of nice, you know, certainly. So yeah. Elvin, does the 0.5 pixel error in yesterday's stream matter a lot? I mean, it seemed a pretty easy thing to overlook. Would it make some calculations erroneous? Typically, off by a half pixel errors just result in slightly worse visuals, except once in a while where they really cause you problems, like with seams or with something that shakes a little bit. So yeah, I mean, what I would say is your mileage may vary. It depends a lot on the situation, how much that affects what you're doing or not. Most persnickety graphics things like that, it's you know, it's really about what the specifics of what you're doing, whether it ends up biting you that you didn't do it right, you know. Soy Sauce the Kid, why are there blank gaps on some of the bars, and why are the collated frames not flush with the other lines? Why are the collated frames not flush with the other lines? I think I might understand the first part of the question, but I definitely don't understand the second part of the question. Can you elaborate more on your questions so I can answer them? Elvin, is there a reason why we have many different starting points for coordinate systems, center versus top left versus top right corners, Windows versus Direct3D versus OpenGL? Wouldn't our alliance be easier if there was a standard for them? Yes, that's true. It would be easier. I mean, the problem is it's not like there's some right answer, and so the reason I think that we have multiple coordinate systems is just because, like as you've seen on Handmade Hero, there isn't like some specific overwhelmingly right place to center the coordinate system. You could just, you know, whatever. And so it's hard, you know, as different systems evolve, they just have different coordinate systems. That's just natural. And with absent some driving force that like goes, okay, we're going to have this big event where we all consolidate our coordinate systems, right? It's just not going to happen. Chrono Dragon, with handling sorting here, will we finally handle sorting of the other sprites in the game, or will we just push that off further? I think probably we should just do all the sorting in one go. Like, because the renderer just should have a sorter, and then we'd use it for everything. Elvin, why do we have both bool32 and int32? That's answered back when we introduce them, so check out the archive, and I talk about that. James Woodman, pretty cool. It does seem like a lot of calls take very different amounts of time, even though they're probably not doing anything different. Is that due to other active processes? Probably not. Probably not all that much. I mean, maybe a little. Are you talking about any particular one? Elvin, how much valuable do you think C++ operator overloading actually is? I'm thinking of fully moving to just pure C. Do you think it would be inconvenient to program without them? Operator overloading for math is pretty important. I probably would not want to use it. In Granny, I did not use it, and I miss it. So operator overloading for math is pretty important. That's what I would say. Cuber Caleb, will you show us how to do hit detection for obscure shapes that may or may not exist in the debug UI? No. Because I don't even know which shapes you would be talking about. I only really show how to do stuff that we have some plausible reason why we might do. Racer NA, have you seen the UE4 GDC trailer, and what are your opinions on it? I understand we are all indies, but just in general from a player standpoint. I have not seen the UE4 GDC trailer, I don't think. Are you asking just for my opinion of how the engine looks? Like, does it look good? Or I'm not sure what you mean. Soy Sauce the Kid, the longer bars, which I assume was when the collation was happening, are farther left on the screen than the shorter bars. So let me see. I'm not sure I understand what you're talking about. So what are we talking about? Are you talking about why these bars don't line up with this bar? Is that what you're asking about? Cuber Caleb, by obscure shapes I mean a slice in a pie chart. Well, there's two different ways that you can check for shapes. A slice in a pie chart happens to be convex, which means you have a get out of jail free card. You could just check the winding order, and it works. If you're talking about obscure shapes that can be concave, like a butterfly shape or something, then you need to do an edge crossing test. Again, really simple. It's like 20 lines of code. You can look it up. Point in Polygon is like pretty simple, right? Like point in Polygon. I don't know if any of these is good. Oh, it's funny. We still don't actually check the active thing. It's pretty funny. So this looks reasonable, right? And so like this looks like a pretty reasonable introduction. I mean, the idea is just that when you have a point, you know that there's going to be an odd number of edge crossings if you're inside it, and an even number of edge crossings if you're outside it. So you can just start looking at the edges of the polygon and see how many of them a single line. In this case, they pick horizontal because it's the easiest one to do. Like a horizontal or a vertical line is going to be the easiest thing to test because it's aligned with one axis. So, you know, you can see 1, 2, 3, 4, 5. That's odd. I must be inside. If I were to move out here, I would have 1, 2, 3, 4, and now I would know that I'm outside because, you know, you get the idea. It's really simple. Okay, Soy Sauce the Kid says yes to my question about his question. So what's happening here, right, is that this is one frame. This is one thread. So this thread goes executable refresh, input processing, game update, you know, blah, blah, blah. This point right here is where the renderer kicks off. And so the renderer actually invokes it pushes those jobs on the job queue, and you can see that we get all of this renderers. So our other threads, 1, 2, 3, 4, 5, 6, right? The other 6 threads all kick off render work. So while this thread is rendering, all these threads are rendering. When they are done, they all stop. We do a little bit more work, and then we kick off a second render, which is right here, which is the debug stuff. So this is actually where our frame would be over normally, but because we have debugging happening, we see these. And this is just, again, the same thing. It kicks off a render. This thread is rendering, but there's plenty of work in that work queue, so the other tiles get picked up by the other threads and worked on. So that's what these are. So the reason that nothing's happening in here is because we haven't multi-threaded anything else yet. So there's nothing else for them to do. These threads don't have any work to do, so they just sleep, waiting for someone to stuff something on their queue. When we get to the renderer, they can. So in the future, what we might try to do is fill those holes with like simulation work or something, Racer NA, yes, the graphics, check it out whenever. Oh, okay, so I don't really need to check out a video for the Unreal graphics engine. It's a totally fine graphics engine. It always has been. And, if you want a 3D, first-person shootery graphics engine, and you don't know how to build one yourself, or don't want to build one yourself, it's quite good quality. It's a good quality renderer. I can't speak for the engine. I have never used it myself. There may be a lot of really bad problems with it or something, for all I know, that would make it very unpleasant to develop with. I don't have any idea. That's not really my sphere of knowledge. I've never used the Unreal Engine or the Unity engine myself. So, your mileage may vary in terms of whether you enjoy working with them. But my experience in general has been that Unity's rendering engine does not look particularly good. It looks pretty amateur to me, whereas Unreal's rendering engine does look really good. And I don't know to what extent that's a fair assessment. I'm just going by what I see them demo and what I see games ship with the two engines. If you're someone who really cared about visual quality, you're pretty much going to go with the Unreal Engine as far as I can tell. But between the two, because like I see, indies don't have access to Frostbite, for example, which also looked quite good to me. Let's see. James Rubin, refunctions taking different amounts of time. I mean, if we don't send any input and essentially the same image keeps getting rendered repeatedly, we still see a lot of fluctuation in the amount of time being consumed per frame. We have a lot of chop where I would have expected relatively calm waters unless we're losing time to other processes on the machine. So, yeah, I mean, if you want to take a look at this as it is, and you're saying that you see a lot of chop there. To me, if I look at this, I actually don't see that much chop. I mean, remember, this is something like, 16 milliseconds of time, and it's coming in pretty darn close every time, right? And so, yeah, is there chop there? Yes, but not really that much. I mean, we probably are losing some time to the system, especially since OBS is running and stuff, but this is actually pretty consistent timings, I would say. Because remember, memory effects being what they are, and, there's so much unpredictability in modern execution. Even if nobody's stealing any time from you, just the fact that every frame is a different processor state as it goes through is enough to make your timings different, So yeah, but yes, I mean, almost certainly we are seeing swap out time in there, I would assume. And you know what, more so than we might not even be seeing swap out time, right? What we might be seeing more of is like the operating system taking a longer time to do something we asked it to do or stuff like that too, right? Like you can look at frame display, look at how long it took there, right? Versus how long it took here. And that's an operating system call. So that's not really about swapping. That's like when it decided to do that. And if you look at the primary difference between these two guys, it was mostly in there, right? So yeah, and so there's some other differences, you know, like input processing, again, that's calling the operating system, and that's what accounted for this shift here. So swap out is not necessarily the same as operating system taking longer to do something for you or stuff like that. Gary Johansson, curious what point represents the amount of time it takes the operating system to set up the parallelism, if parallelism is the right word. Right now, we don't have a very good way of viewing that, unfortunately. And the reason for that is we haven't really finished doing this sort of drill down thing. So what happens is, you know, we drill down on something like game update and render, we lose these other guys because they are not underneath him. You know what I'm saying? So what we want to do is get down to here, where we can see tiled render group to output getting invoked, and then look at how long it takes for the other threads to kick back up. And you can kind of see, well, unfortunately, we're going to get a different set of frames, so there's really no way to even look at it there. Yeah, we're a little bit before we could really do that. We could really see what you're asking for. So I'm sorry about that, but Huber Caleb, do you know why one of the worker threads started after the others? No, I don't. You know, in general, I don't know why you sometimes get, you know, Windows might decide to do something kind of a little wonky with when it's kicking people off. I have no idea, right? You can definitely see some anomalies there, and I don't know what they are. That's just Windows is doing what Windows is doing. We might have a bug, so when we get into when we try to start to like nail things down harder, you know, many months from now, when we're like trying to drill down on like performance issues and things, you know, shipping work. That might be something we have to look at. It's always very hard to say, right? So yeah. Elephant, every once in a while it seems like a frame gets missed. I've noticed that happens in things I do as well. Is there a way to get around that reliably? Not on Windows, no. There's definitely things that we will be doing in the future which will minimize it more. Like, for example, not going through stretchblit. So when we're going through like OpenGL as the way to display frames, that will help us not miss frames because that's going through a pipe that's supposed to be for on-time delivery. Unfortunately, even that just doesn't help you. Windows is not even a soft real-time operating system, let alone a hard real-time operating system. Windows is just bad at that. It's bad at that. I wish they would put more effort into making that work. They don't. And so as a result, you're going to miss frames on Windows. Full stop. Even people who spend like all their time trying to not miss frames on Windows, like the VR guys, still have problems where every so often, every couple of minutes, they miss a frame. And the reason is because Windows just decides to swap them out and redraw, you know, the title bar on Visual Studio or something, and you miss a frame. Like I said, wish Microsoft would take that kind of thing more seriously. They never have, and they probably never will. What do you think of the theory that says we already know everything, all the knowledge there is, but we just don't remember it? So when we study, we start remembering things. I think that is I think while there exists constructions of the universe for which that could be true, I think even in those constructions, that is a very poor way of stating it, because the term that people use when they say remember or know, that is obviously not true, right? Because we've seen how neurons get built and stuff. And so, you know, what people think of as knowing and remembering, it's obviously not true that we already know things, we just don't remember them. But an alternate way you could think of how neurons worked was if there was some, you know, global system in which knowledge, there's a specific configuration for every individual piece of knowledge as the brain conceptualizes it. So every configuration, and all that's happening is your brain is actually sort of placing one of those into itself as it becomes something that enters your brain. You could argue that there was something like that where every configuration of knowledge is already exists, and it's just your brain is like placing new ones in or something like that, I suppose. In general, it sounds like a pretty stupid statement to me. Because I guess the closet, the capsule review. All right, looks like we've come to the end of the questions. And I'm going to have a little mini announcement after the stream is over. So if you would like to stick around after the fact for Handmade Hero friends, I will have a little brief announcement. Yes, thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. I'm excited to see our debug systems slowly start to come together because I like being able to inspect what my program's doing. And we've been flying blind for a while because we've just been working on other things and it was important to kind of get everything up and running. But now that we have a relatively good foundation, it's kind of nice to start to be able to see what things are actually doing so that we can figure out what's not working well and also be able to troubleshoot problems and get all sorts of kind of like nice higher level sort of feel for what the code's doing. It's pretty cool, and I'm very glad that we're getting that now. So that's what we'll be doing next week. Now that we've got the ball rolling, I think we should just keep on rolling it and put in some pretty cool stuff, kind of get that UI working so it's pretty easy for us to kind of go in and inspect things. And so that's what we'll be doing. Hopefully you'll come back next week for that. And if you want to know the schedule for that, always check the tweetbot. This guy right here from handmadehero.org, you can go to the tweetbot. It tweets the schedule, so you can always tell when we're going to be live. In the meantime, if you would like to follow along with the source code, you can always pre-order the game on handmadehero.org, and it comes with the source code even as we are developing the game right now. Every night after we're done coding here, I upload it. So if you want to play around with that, this is the place to do it, and you can use it. You can get it by downloading a zip. There's also a sort of unsupported GitHub that you can use that it comes with if you're a Git kind of person. So you got options there. We also have a forum site you can go to ask questions and a Patreon page you can pledge to support the video series. Check those out. If you like the series, they're good places to go. That's about it for today. Until next time, I will be back here on Monday. Until then, have fun coding over the weekend. And I will see you guys on the internet. Take it easy, everyone.